Yes, we are often asked here through the FAQ on our website or at seminars as I travel across the country what it means for a driver to be pistonic. With the help of a machine made by a company in Germany called Klippel, we now have the ability to look at the cone's behavior at all different frequencies with a laser that will give us a very accurate picture of the behavior of the cone. And as we look at one of these plots that are provided by this system here on the screen, you'll see here that we have two of them side by side. The one on the left is our patented balsa carbon fiber cone, and the one on the right is a very high-end paper coned mid-range that is the same diameter, also a mid-range. And as you can see in this case, they're both blue. These two are synced as they go through their motions. And what you have here is the colors are blue and red. And when the direction of any part of the cone changes or reverses itself, reference to the rest of the cone, and then you get a color change. In this case, it's programmed to turn red. Remember, the voice coil is attached here in the middle, so that's your primary color. That's what the voice coil is actually trying to make the entire cone do. So pistonic basically means that this entire cone is moving in sync with the voice coil that's driving it. So we'll see here, at this case, we've got the two of them, we're at 600 Hertz, and we'll let them go through their motions. And you can see that both our carbon fiber balsa cone and the paper cone are acting as pure pistons. Every bit of the surface area on both of them are moving in the same direction as the center here where the voice coil is attached. Let's, however, take a look at 1400 cycles. In this case here, you can see that we have blue here, mostly blue here at the transition point. But as it goes through its cycles, about half of the paper cone is now already, let me run it through that motion again, already, if I could stop it at the right point here, anti-phase, where half of it is going in the opposite direction of what the voice coil. Again, the balsa carbon one, cycle one more time, we see is in perfect unison with the driven part here. So now that's only 1400 cycles, very critical frequency for a mid-range. Now, just for the fun of it, we'll push it up a bit and we'll have a look at it at 5K. Still considered to be mid-range frequencies, would certainly be in the overlap area of a mid-range when it was crossing over to the next driver. And again, we'll run it through the motion and you'll see here that the balsa carbon fiber one is basically staying blue and is tracking what the voice coil is trying to do virtually perfectly. In the case of the other one here, you see that this is just almost mountainous. I mean, wow, it's there's in this case here we have almost all of it except for the rim totally out of phase, or no, it's actually in phase, but the rim is out of phase. Sorry about that, but and you can just see that the chaotic behavior is. Now what this causes is losses of information within the diaphragm or the cone that's creating the pressure wave in the room to engage our eardrums so that we can hear what the amplifier sent to the speakers. And as you can see, about the only way to describe this would be chaos. This is why in most speakers every other driver needs to be out of phase, because as you go to the higher frequencies, a very high percentage of the cone is actually out of phase with the rest of the with the voice coil. So in order to get it to blend with the tweeter, which would be pistonic, it would have to be out of phase to be in phase, if you can understand what I'm saying. This represents a tremendous amount of chaotic behavior in that cone and a very, very high amount of loss of information. This might be preferable in a speaker of low cost, in a low cost system where the electronics and the source and maybe the cartridge and the turntable or the CD player is of limited quality, and you may not want to hear all of the information that's there. Having this much loss in the code might be beneficial. But at the price point of these drivers here, which are very expensive high-end drivers used in high-end loudspeakers, in this here, the 5A, in our case, the 5A Carbon and the Model 7 Mark II, this one here is also used, a very expensive driver, used in expensive high-end loudspeakers. You don't, when you're talking about thousands of dollars for cartridges and hundreds of thousands of dollars invested in the system, one is not wanting to lose this much of the information at the end of the chain. You paid a lot of money for that information only to lose it within the cone with this kind of chaotic behavior. Now, tweeters, of course, do the same thing. Soft domes go into this kind of breakup somewhere between 4,000 to 6,000 cycles. That's why they're called soft domes, and they sound softer. However, they are very lossy and they do lose information. So hopefully this, again, one more time on this, I just love seeing it. It looks like a mountain range going through there around the edge of the cone. Hopefully this gives you a pictorial of what it means to be pistonic.